I give you a very short introduction into what a knowledge graph is to not bore the others, and then I'll go ahead with the real technical things because there's a lot of stuff going on in the knowledge graph development. As you were telling in the introduction, thanks for that, the knowledge graph is what we call the one-stop shop of metadata management in EBRAINS. And yes, I'm saying EBRAINS. We're really proud that knowledge graph is one of the first services actually wrapped into the new EBRAINS framework. Beforehand, it was the HBP knowledge graph. So no matter what you've heard, if people are still talking about the HBP knowledge graph, it's still the same. Basically, it's about that circle here, share, find, and use. What does that mean? That means that we won't really enable people to find the data that is created in the HBP and outside, like in the whole neuroscientific community. To be able to use it, I mean, you need additional information for being able to process a CSV file with 1 million of columns and whatnot. You need to know what that one is. So we want to support the use of the data that is created. And obviously, we also want to support you to share either your results, so meaning your derivative data, but also your original data that came directly from experiments. In that whole chain, we have built several tools. One of the most prominent and one that you can immediately see yourself is the search UI. You can access it via kg.ebrains.eu/search. And there you can already find in a typical search UI manner what is in there, what is in the graph. Now obviously, as you can imagine, that's just the facing things. There's a lot of stuff going on behind it. I'll just quickly skip that one and go to find because that's the one we will spend more time on it. So how does the data get into it? Well, we have that share part, meaning on one hand, there's obviously APIs for you if you have your database with already ingested metadata that you can put that stuff in by script. But we also do have our knowledge graph editor, which is mainly there for the curation team, because one very important thing about the knowledge graph is that all the data that goes in there is quality approved. What does that mean? One researcher might call it X, the other one might call it Y. For making it actually findable and reusable, we need to converge on definitions, on ontologies, etc. And that's where the curation team comes in. They're doing a review of the data. They consult you in how to annotate the metadata. And their main tool, how they're working in, is that one. Additionally, we have a staging mechanism in the knowledge graph, meaning not everything that you edit here and save is immediately appearing in there in the search UI that you've seen publicly. You have this quality gate, or kind of quality gate, not in the sense of is the data qualitative good, but rather is the metadata written accordingly to our standards. So the curators check that and they actively release it, meaning you do have, like some staging mechanism, and only the stuff that is really validated is then kind of going out to the world. I wanted to go back, sorry. So use, we do have different APIs, as I was saying. And as you can imagine, if you ever worked with a graph database structure, it's quite tough because you need to know exactly where the graph goes and so on. So ourselves, we also had that issue by building the clients that we did. And we decided, we need a UI for that. And that's something I want to quickly show you. So we have inside the editor, that one will be split apart at some point. We do have like our different entry points because you do have different entities in there. And I have that wonderful example of The Simpsons. Let's say I would like to know about sayings that appear in The Simpsons. Hopefully everybody is aware of them. If not, please check out. So I'm looking for the name of a saying, but that's not all I want to know. I also want to know by whom it was said. I want obviously the family name and the given name, please. And I also want to know in which episode that one came out. Let's say, the name of the episode is fair enough. So I've quickly clicked together my query that I want to ask the knowledge graph. That one is the actual specification of that query. And what you're already guessing, you can take that payload and just throw it at an API. You don't have to go through the UI all the time. Actually, we encourage you to do that. And what you also can do is you can immediately ask here and check if what that was coming out is right. So can you see it, or shall I increase the size a little? maybe for you. So what we see here is the results, and we have the naming Ay Caramba. Does anybody know from whom it has been said? Should probably be Bart Simpson, right? And then there's episodes. We are not complete with the Simpsons data in our knowledge graph because that's not our main topic, but still, I mean, we have at least this episode information. Now, why is that interesting for you? One important thing is we are working with JSON LD behind the scenes, means we do have fully semantically valid keys, and therefore, yeah, we are semantically correct. Now, typically what a client wants is JSON, right? All of us want JSON because JSON LD is super tough to work with. If you have dots and special characters in your key names, it's just a pain. So what we decided to do is we decided to put an abstraction layer on the query API that we're providing to you, meaning, honestly, I think, wait a second, oh no, that's with the zoom level, huh? I quickly go back to that. Here, can I zoom? Yes. So originally, if I wouldn't apply tricks, that's what you would see in the payload, right? Blah, 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 super long namespace in there, etc. Now, the thing is, those could all have different namespaces. So what we offer you is to rename and to change the structure at query time. So one thing that we do is, first of all, we give it a vocab, saying, please rename everything to my single namespace, because when I'm querying, I know exactly what I want. I don't need the original semantics anymore. And then I can just wipe that one out, and what I'm ending up with is basically JSON, right? Because it's all the same namespace, I just can get rid of it. Another thing that you can do is, you saw now here in our episode, that there's this ugly multi-nestedness, right? You have this episode, and then you have a name in there somewhere structured. Now, I don't want to do that because I only have names in there. That's the only field I've selected. So what I do is I go here, I click on flatten, and guess what? Pop. Episode now is not an object with a name in, but it's just a string. So what we basically provide you here is, again, you can specify your own query and therefore your own API to the knowledge graph, just containing that information, just containing that little excerpt of the graph that you actually want. Conveniently enough, you can save that one. Let's call it CodeJam 10 demo. You can save that one, and now there's an API endpoint where you can just send a GET request to CodeJam 10 and you get your results back. That easy, right? If we change the data structure behind the scenes, if we put another element in between the episodes and whatnot, you don't care. All you have to do is to update your query because you did the flattening thing. You don't really care. You're still staying stable. You're still staying connected. Yeah, so that's kind of just the first thing that I wanted to show you, probably something that could be of interest if you want to consume data. Let's see, there's probably the full screen somewhere. Yes, here. So that's what we have. But obviously there's some, right, we exist since more than a year, meaning there's also some things that we've learned. Hopefully you learned stuff within a year. And we needed to do some some new updates for making sure that we can properly maintain all we did. So what we came up with is a new KG ecosystem, which I'm happy to explain to you. This one is coming up pretty soonish. So there's a phased rollout of that one. Basically what you can see is that we do have like a simplification. For those of you who are already aware with how the API look like, we have like a multitude of APIs for compatibility reasons mostly. But we are really doing a consolidation of them, meaning that you can ask, for example, for instances, you can query what I just shown you, but also for structure, and especially the last one is quite powerful. So we're all wrapping that one into the KG core, which is a microservice architecture. For those of you, by the way, for all the slides, if you want to know more, just step by me because I can't really give you a very, very superficial overview. And again, we do have like this exposure of APIs. There's a new authentication system. I don't know if you're aware of that. There's a new authentication system coming for HBP and EBRAINS. And another thing that we really integrate, which has a lot of impact for you as the consuming or ingesting clients, is proper management functionalities of our several clients. The instances API, this one is mostly there for people who want to get stuff in. So basically, what you would expect, it's CRUD, right? So you can create stuff. A very important thing here is that we don't necessarily need a schema. If you have been ingesting data into the knowledge graph via the Nexus API, you always had to kind of create these schemas and so on. We're relaxing that problem, meaning we're taking almost everything, and the validation of if it's correct or if it's sufficient for a client happens at query time instead. So we were shifting the validation from ingestion time to query time for making the most dynamic or kind of the most flexible way available for the different data. Yeah, there's no surprise in the readed list, but there's a contribute which is important. I said it's CRUD. It's not really true. The update missing is part, because the update is actually the contribute. What does that mean? We do have kind of an inference and mechanism included, meaning that if you upload a document to us, you're contributing to an entity. Let's get into the example. Sorry for the Simpsons all the time, but I think it's easy to understand that way. So you're uploading that payload here. You're declaring, I'm talking about simpsons.com/Homer, and I give my family name, I give the family name, the given name, and I give links to Homer's spouse and Homer's children. That's what I'm saying here in JSON LD. Now, out of this, if I, well, sorry, touch screens are stupid if I'm gesticulating a little. What happens with this one is it gets uploaded, it gets its own UUID. Next time, I did that. Now another contributor sends something to the same ID. It's like, I have also to say something about Homer. I'll add the age, for example. What happens is there's still only one Homer Simpson, right? It's still one ID. But we infer the information from the different contributions. So what we'll end up with is having a family name, a given name, and an age, or whatever other information that you're giving to us. This is especially important because that's also how our knowledge graph editor works, right? So in the knowledge graph editor, there's data providers adding information, and there's curators adding information, and there's debates about the right thing or not the right thing. So it's very important that we keep the information separated from whom it was coming. And basically, the inference mechanism then is trying to consolidate that thing and to generate the temporal truth, which is then validated, as I was explaining, in the release mechanism. There's another thing written up there called lazy identifier resolution. Previously, what you had to do when you were uploading a full graph is you've created one instance, you've uploaded it, you memorized the ID, you took that ID to link to it from other instances, right? That's how you did it because the ID was given by the system. That's really, really tough to do if you have big graphs, meaning you do have like to know exactly in which order you have to upload things so it actually works out. And if you have recursive relations, that's just, yeah, really, really bad. What we integrated with the new logic, though, is that you can, as you see here, use external identifiers. So that simpsons.com/part will never be an ID, like a native ID of the knowledge graph. That's all we know. The native ID will be a UUID that we don't know about. But I still can use them already for linking. Like I can say simpsons.com/part is a child of Homer Simpson. And if I upload that other thingy here, with the ID simpsons.com/part, the system knows and the system automatically resolves the right ID and properly assigns you with the graph. What that means for you, basically, is you can prepare all your stuff with all your IDs, self-defined or defined somewhere externally, upload all in one go, and the system will take care of resolution. It goes that far that you can even say, I know there will be simpsons.com March somewhere. I don't have that payload, but somebody might upload it at some point. The system accepts it, meaning it's up there, and as soon as there's some information coming in about simpsons.com/March, you will get the relation for free, so to speak. By the way, this also works with schema.org identifiers. If you guys have a wish list of other semantical keys that should be regarded to do that, please tell us. The query API I already shown you. For those that were really checking out correctly, it was still schema-oriented, meaning you still were asking for the saying in version 1.0.0, which works, which is not super nice though, anyways, because you know a lot of the internal structure that we have. So in the new way, we're not asking for schemas anymore, but we're asking for types instead. So this becomes way more natural. You're actually asking, give me all the persons. I don't know where they're stored. I don't know in which version they're stored, but just give me whatever you have in types of persons. And that's what I meant with validation at query time. What you're saying is, give me all the persons that have a given name and a family name. I don't care about anything else. I don't care about schemas, but that's what I expect from my person. And if you can fulfill it, it's good enough for me. So that's definitely a big change, but still quite comfortable with what we already have, meaning don't get yourself stopped with saving your own queries. There will be a nice migration path for the old queries to the new ones, pretty straightforward, and all you do is kind of you can profit from the new development there. Just need to quickly check, because I know that I'm always running late if I'm starting to talk. Still there's some minutes left, that's great. So another thing that you can do now, I've shown you that vocab thingy, right, where you can retranslate vocabs and rechange the structures. We extend that capability even, so you can send in full-blown JSON-LD context that should be applied. So you can do quite complex stuff with that one. You can mix namespaces. You can really kind of create a different representation, so to speak, of your data, regardless of how it was structured internally, to another format. This is very helpful, for example, if you have stuff like, let's imagine the datasite metadata schema. I don't know if you're aware of that. Dataset has these DOI schemas that they need, so they get information about contributors, authors, etc., etc. But they expect it in a specific format. Google dataset search as well, by the way. So, I mean, what we can do then is we just write the right query that translates our information the appropriate way into those kind of namespaces that are expected, and here you go. You don't have to change your underlying data schema, you're just putting a view on top of it, so to speak. Yeah, there's other details like native filters, something that is also missing, that if you create a query, that others can start to edit it as well, but obviously only the ones that you want to, so there's new permissions there. Another thing that we're working on, and that's what I said, that could be interesting for you as well, is the management API. Because right now, what we had is, well, let's formulate it that, with the technologies that we had, it was like cumbersome to actually integrate technical clients. It was quite straightforward so far to integrate users, just like that, but like technical clients accessing our data constantly was still a little, yeah, it took some extra efforts. We worked on that, meaning, on one hand, the new authentication system will relax the issue. You will get proper client secret access to the graph, etc. But also, you can kind of configure how the knowledge graph should work for your client and for your space. Meaning, we do have, like, spaces, by the way, are a concept of, like, a grouping of data. Let's say you have a script uploading some very specific data on a field. And now, I was talking about that releasing process. Theoretically, what happens is you upload that stuff by script and somebody has to go through manually and see, like, validate, yeah, that's correct, yeah, that's correct, yeah, that's correct. Which is a good thing because it's quality control. But on the other hand, if you have a trusted system that you know that that stuff is right and that the only thing that can happen is a technical error, you probably want to go for an auto-release mechanism. That's not true for all. Some of the data is, metadata is created manually, some of them is not. Meaning you can actually configure your spaces to auto-release your stuff and therefore do shortcuts and don't have to write that one in your code, calling extra APIs, etc., etc. Again, there's a lot of other things. Yeah, I think I don't go into that one. So Next check. Okay, now I have to hurry. Oh, thank you. Perfect. So, yeah. One very important thing is the structure API. Now, you've seen that I was picking these different properties from that UI, but how do I know what actually is in there in that graph, right? I should know what the structure is. So, we do have like a mixed approach, meaning on one hand, you can specify beforehand something we call contract first, what will be part of a person. Let's say a person will always contain a given name and a last name. But there's also the possibility to say, well, the payloads themselves define what is going in, right? If I specify my person with given name and last name, and I upload a payload which contains an age, I have two choices. Do I ignore the age because it doesn't fit my schema, or do I just add it? We decided to go the open world approach, saying we just add it. It's just another property, so a person can have an age. Hooray, we learned that implicitly, although nobody defined it. It's just there in the payload. So that one means that the structure itself is highly dynamic. And that also means that your clients, if they want to know what is accessible, need to be able to ask for how does the structure look like. And that's what the structure API is for, basically. So far we had that one, as you've seen it in the query builder. We had that wonderful tree where I was able to click through. Problem is that information is super expensive to get from the graph. If you can imagine, like if you have to traverse the full graph and always see what is there. In the new version, we're actually doing that differently. We're really indexing the structural part at ingestion time, meaning we always have a live view on it, making clients like an editor very, very fast responding and also behaving as the user would expect it. And additionally, we also provide you the opportunity to add information to the metadata of the metadata, meaning you can actually give, say, family name has a human readable label, right? It's family name, hooray, but with a space in between and not in camel case. So you can add that additional information to your structure and transparently query it. So if I, on the editor, give a human readable label to a property, another client can make use of that one. Or I could decide, well, it's fine enough that the editor calls it family name. I would like to call it last name, so you override it for your client specifically. Because we have this management APIs, etc., all the APIs, the structure APIs, the query APIs, will behave transparently to you depending on which client you are, making it quite convenient. At least that's my opinion. Yep. We've worked a lot on permissions. I could fill a full hour on that. I won't. But just that you know, there's a lot going on in terms of granularity of access permissions and cross-space permissions. If anybody is interested in that, I'm more than happy to explain that, what exactly we were doing there. For those of you that have integrated with Nexus already, like with the Nexus API, don't worry. We are keeping compatibility, on one hand, with the current Nexus version 0 that we have, but we also integrate soonish the Nexus version 1, which is the current version of Nexus. For those of you that don't know, Nexus is a graph solution which is built by the Blue-Brain project and extensively used by SB6, but also by others. Yeah, so we kind of have these interfaces in addition to the APIs that I was just showing you, which are for convenience mostly. Yeah, again, I already said that, and other backwards compatibility issues, I already said migration paths are existing for the current clients, so don't worry too much about that. My time ran out. As I said, there's a lot of more to talk about. If you have any interest, visit kg.ebrains.eu, send an email to us, or what we prefer, especially now that we are co-located here, have a coffee with us, or we could also do coffee time over video conference if we don't manage today these days. Thank you very much.